Hello guys, I hope everyone is fine. Welcome to this new video session on coding practice. We are going to take up another popular problem today, which is important from the point of view of placement drives. It is an important step in preparing you for that placement practice or placement preparation. So without further delay, let's go to the problem. The problem is you're given an array and you're also given an integer k. So I'm supposed to write a program which finds the maximum element in each subarray of size k. Very simply, I'm going to deal with a subarray here. Subarray, as we are going to assume in this case, I'm going to deal with a consecutive block of elements, which is referred to as the subarray. So let's say this is my input array 1 2 3 4 1 2 3 5, and my k is 3, so my subarray is going to be 3. So if I look at the first subarray of size 3, it would be 1 2 3. The maximum here will be 3. The next subarray of size 3 will be 2 3 4. The maximum in this particular subarray is 4. The next subarray is 3 4 1, and once again 4 is the maximum in this particular subarray. 4 1 2 is my next subarray, and the maximum here is 4. 1 2 3 happens to be the next subarray, and 3 happens to be maximum here. 2 3 5 is the last subarray of size 3, and 5 happens to be the largest among the elements in this subarray. So very simply, you are given an array, you divide it into size of k. Here k is 3. So when you have divided it into size of 3, what you're going to do is we are going to check out which is the largest element in this particular subarray. Now once again, this problem can be solved in a variety of ways. What we are going to do is we are going to look at one of the naive ways, or the brute force way of coming to, or straightforward way of coming to the solution to this particular problem. So our approach is going to be naive. What we plan to do is, let's generate all subarrays of size 3, and let's calculate, or let's find out the maximum among these subarrays. So our approach will be, let's go ahead and let's generate all possible subarrays of size 3, and from this, once we have done that, let's find out the maximum. Okay, so without any further delay, let's jump to our code here. I'm going to create a new file. The name of the file is maxnk.cpp. We're going to use a new file here. So let me include iostream. Let's use the standard namespace. Go into the main function. Let's deal with the same array here. Let me copy it. So I will go ahead and I would copy this. Let's jump back to our code. Here, integer a equals this particular array. Let me use a variable n, size of a divided by size of a0. So this n will hold the size of the array. So if I were to print n at this point, I would be getting 1 2 3 4 5 6 7 8. N would be printed as 8. Let me also take k to be 3. So my plan is the same as in the slide. This is my subarray. I would plan to split it into 3 subarrays, or not 3 subarrays, into subarrays, as many subarrays as possible of size 3, and then find out the maximum from each. So let's start. I will use a loop which runs from I is 0, I is less than equal to n minus k. Now remember to write down less than equal to. Why n minus k? There is no point in going after this particular portion. 2 3 5 is going to be my last subarray of size 3 here. So let's say if I just had a little bit of discussion on it, if I just had 1 2 3 in my array, right? So if I wanted a subarray of size 3 which was equal to n, if I did not put an equal here, I would simply end up with the equation n minus k would give me 0. 0 is not less than 0, so this would not give me the right answer. It's important to write down less than equal to from this perspective. I'm going to declare a variable max, right? The purpose of max is to hold the maximum value in the subarray. Let me start another variable. J will run from I till the time it is less than equal to I plus k j plus plus. Okay, so here I will perform the check. If aj happens to be the value greater than the value in max, so max should take the value of aj, and once I come out of this loop into the outer loop, I will simply print max, and I'm going to do an end line here, right? So I ended up using two loops. Let's see if it gives me the right answer. Let's go back and compile this code. G++ max inc.cpp, and let me do an a dot out. Okay, I'm getting 344435, 344435. Let's go back here. 344435 is indeed the answer. Okay, so we managed to get to the solution of this problem. What we are going to do is we are going to analyze this code in detail. So the first line gives me the array A. The second line gives me the size which goes into the variable n here. The third variable is the size of my subarray k, which is 3. I run a loop. I is equal to 0, n in this case, as we found out, n is going to be 8 here. So let's do a dry run of this code. So in this dry run, so what happens? I is 0, I is less than equal to 8 minus 3, which is 5. Okay, so you give a value of max, max gets a value of 0 rather. J is equal to 0, j is less than 0 plus 3, so it's 3, j is less than 3. You check, is a0 greater than max? Of course 1 is greater than max, which is 0, so max will take the value of a1, so max will contain 1 at this point. Okay, j increments, it becomes what? J becomes 1 at this point. 1 is less than 3, so I'm simply going to check, is a1 2? Is it greater than max? Yes, so max would change from 1 to 2. J increments again, it becomes 2, so I'm going to ask the question, is 2 less than 3? Of course it is. So a2, which is 3, is 3 greater than 2? Yes, so max updates. J again increments, becomes 3. 3 is not less than 3, so I come out to this line, cout max, and I end up writing 3 and a space next to it. I in the next iteration is going to become 1. 1 is less than equal to 5, n minus k. Remember, n is 8 and k is 3. I will set max to 0 again. J will become 1. 1 is less than equal to 4. So I would check here again, is this is the index here, a1 is 2 greater than max? Yes, so max becomes 2. J increments, it becomes 2 here. So the next question I'm asking is 2 greater than 3? So max updates to 3. Next question that I ask is 4 greater than 3? Yes, it is, so I will end up printing 4. The next subarray that I consider is this. The next one that I consider is this. The next one that we consider is this. The last one that we consider is this. So moving in this manner, the outer loop helps me go ahead and divide my array. It helps me cycle through the indices in my original array. This is the loop that actually goes ahead and prints all subarrays of size k. Along with it, I perform a little bit of computation. I check whether the value is greater than the max element. If I have, I update max and I end up printing it. So this is the code here. This is the approach that we have taken, a very naive, a very straightforward approach. Is there a better way of doing this? Of course it is going to have a better way. Of course there is a more efficient way. Just to update you, the time complexity of this code is going to be big O of n square. I'm going to write it like this, big O of n square. So stay tuned for the next video session. That's it for this one. Take care. Thank you.